Hello and welcome to the practical part of the state pattern. Now, in the previous video, we spoke quite at length about the theory behind it. Now let's look at what we can do with it and how we can implement it. So I've prepared a little example for you and we're going to dive into that right away. Alright, so now let me show you what we're going to create here. We're going to create a game of catch, and as you can see, these cubes here try to catch one another. I mean, there's always one guy who is red, and that's the catcher. The other guy try to evade him. And yeah, you can already guess. I mean, the cubes are the AI. And I have three different states. Now, the first state is the one who is the catcher. He tries to catch the guys. And then I have two different states for how to evade the catcher. Now, everybody starts out in a taunting state where they just try to keep a certain distance to the catcher. However, once they are caught, they are no longer as cocky and they no longer taunt you. Instead, they don't try to keep the distance, but they run as far as they can from you. So you can see those two guys here and here. I already caught them once, so they hide in a corner and are really afraid of me. So when I go like this, they shit their pants. And if I just catch one of those guys, they're also not as cocky anymore and try to run for it if they're not blocked by the other guys. Yeah, like this. Now you can see this guy also peed his pants and won't taunt the catcher anymore. So yeah, that's just it. We have three different states. Now let's look at how we can implement the state pattern with this. Now, another thing to mention is that you of course can download the starting version that I currently have and the finished version of this project in the description of this video. So feel free to just download one of those, whether you want to do it with me or just watch the finished code. Right. Now, I have a few classes here. I won't go too much in detail in them. Now, let's just look at the character. We have two scripts that are on every participant of the game. You have the catch participant. In this script, there's the logic for getting caught and catching one another. It determines whether you're a runner or a catcher. It sets you to stunned and so on. So this is like the game logic part. Now, also, we have got the player controller, and this is a very simple script. This is just responsible for getting the input and then telling the motor of the object to move. Now, I like to separate the motor from the input so I can reuse the motor for the player and the enemy. So if you look at the enemy and compare it to the player, they're basically the same thing. They have the same mechanic for moving that's built in the motor. And the only difference is that the player has the player controller script and the enemy is controlled by the AI. You don't have to do anything with this. You don't have to do anything with this. This is the thing we need to solve. So we are going to have to program the AI controller. And I'm going to do this by starting in a fresh project where this stuff isn't already finished. Now, the first step that I'm going to take is I'm going to create the abstract state class. And this is the class which every state the enemy can be in must inherit from. So the first thing we're going to do in here is we do not inherit from mono behavior. It's a standard C# class, and we set it to abstract. Now, next, I will clear those comments and I'll create a reference to the game object and the state machine. We don't have the state machine right now, but we are going to implement it very soon. So just trust me, we're going to need it. I can remove the start method. And next, I will create a constructor for this class. And lastly, I need those methods that are called when the state is entered, when it is left, and then update and fixed update. And I'll just copy those in here because I'm a little bit lazy on writing all of them. So let's make this a little leaner. All right, that's our abstract state class. Next, we are going to define the state machine itself. So if I go back to Unity, I create the state machine also in here, and I create a script called state machine. Get in there. And this state machine too does not derive from mono behavior. It does not have a start or an update method. It just has a reference to the current state. Now I want to automatically call the enter and the exit method of our state script whenever the state is changed in the state machine. So that's why I'm going to create a property. I hope you're familiar with those because they are quite handy when programming. So let's create it. Now, if you're not familiar with this syntax, this is basically just short for saying, if you get this property current state, then return the current state variable. Right. The set will be a little bit more complex. So whenever we set the current state, we want to say the current state that it was actually in. We need to call the exit method of that. Then we say the current state equals the new value, so the new state that was set. And then we say in the new state, we call the enter method. So that would be rather easy. Now, there might be some edge cases where we should check if the state was set to null, because the first time you create your state machine, the current state will be null. So you don't want to call null.exit. So check this: if current state not equal to null, only in that case you call the exit stuff. And you might also want to check this here. Depends whether your current state can be set to null. Could happen, so I'll just add it in here. Yeah, and that's already the state machine. That's what it's responsible for. So very simple stuff. And the next thing that I want to do is to integrate the state machine into the enemy. So let's go to the AI controller. And in here, I'm going to create a reference to this state machine. Then in the awake method, I create a new instance. And then I might also immediately set the state of the state machine. I usually do this in start. It might also work if we do it in here. sm.current state equals to new state. And to the state, we need to provide it the game object that this AI controller is on, and also the state machine that we want the state to run on. Now, it creates an error. And if you know what abstract does, you should be familiar why this error exists. Now, it also says you cannot create an instance of the abstract class state. Okay, now the reason being that we did not yet create a specific state. So this is just a general abstract class, but we need, for example, a fleeing state where the enemy runs away from the player. So I'll just set it to fleeing. We're going to implement this state right away. But there's a little more we need to do in here. We also need to do something in the update method, because we need to say that the state which is currently set needs to call the update method. So we are delegating the update method to the state that is currently set. So let's do this as m.currState.update. And we do the same for the fixed update. Right. And that's it for the AI controller. So you can see it's very, very lean, that there's not too much going on, because how the AI behaves should be ultimately determined by the state that it's currently in. So let's dive into the fleeing state. So we save all of this and create another class, call it fleeing state. And I just remove all of that. And this fleeing state should derive from the state class that we created. And now we can see we have a problem here. And the problem is easy because we have this abstract state class, which has a specific constructor, 2 parameters, and we have none in here. So let's derive from this constructor. However, we won't do anything funky in here. Now, the next thing that we need to do is we need to override these methods. So let's just write override and override the enter method. And we also override the update, fixed update, and exit method. Okay, so now we're overriding everything. And I'm pretty sure we are going to need 2 very important things in our fleeing state. Now, we know this state determines how the enemy should move when it's fleeing from the catcher. So I'm definitely going to need the character motor in order to move this enemy. So let's create a reference to it. And then we need to use get component to get our character motor. So we do this in the enter method, and we try to say char motor equals get component character motor. And it says we can't do that because get component can only be called from a game object. So now you might see why we need to provide the state with a game object when we create it. Now, I've already done the initialization of the game object in the parent class, and we set the game object to being protected. So we're going to just use that guy. And we can say _go.getComponent, because that's already set in the constructor of the base class. The next thing that we're also probably going to need is the catch participant. I already said it, it's basically the logic of the catch game. So let's create a reference for that too. And again, here we're of course also going to need to use _GameObject.getComponent. And now we're finally good to go to create the actual behavior of our enemy. So you see, this is the huge downside of this design pattern. There's quite a bit of setup to do before you can start doing anything AI specific. Now let's think about what we need to do. We want the enemy to just flee from the guy that's currently the catcher. So that might not be too hard. I probably won't even need the update method. I probably also won't need the exit method. So I created them for Node here. I'm sorry for that. But yeah, things happen. Now let's look at the fixed update method. This is where we are going to move our character. So the first thing that we're going to do is to create a variable that determines in which direction to move when you're fleeing from the enemy. So let's start with that. Okay, so let's look at what I coded right here. Now, we have the fleeing direction. That's where we need to flee from the catcher. I hope you're familiar with vectors because we're going to need them right here. So what we're going to say is we want to move from the catcher. That's this guy. I used a static variable here. I know, not the best coding style, but it's easy to understand and keeps it simple here. So we're using the position of the catcher, and from the position of the catcher, we want to move into the position where we are on. So we get the direction from the catcher to us. And then we set this whole thing to being normalized. So you won't get faster if the distance between you is further. We normalize this vector so its length is always 1, no matter how far away we are from the catcher. And then we just say the character motor dot move direction, so the direction in which the character motor should move is this fleeing direction. Let's try this out, shall we? So we save everything. We go back to Unity. Now we don't have any errors, and we hit play. And as you see, the guys are running away from me because I'm the catcher. And if I move a little bit down here, yes, they are definitely fleeing from me. Now, watch what happens when I catch somebody. Well, he doesn't do anything. He just stands there doing nothing. And if I get caught again, he runs away. So we only implemented the fleeing behavior, so it's just natural that currently he doesn't run towards me when he is the catcher. Because, I mean, of course he should run towards me. So that's what we need to implement next. And now we can see rather the beauty of this state pattern, because that can be done rather easily without doing anything in the enemy behavior. Now, the first thing we need to do when we want to create another state is create another script, and I call it chasing state. And we jump in there. And of course, we're not inheriting from mono behavior, but rather from the abstract state script. Now I'm cleaning this stuff up in here, and the stuff that I'm going to paste in here now is pretty familiar to everything we've done before. So need a reference to the motor, need a reference to the catch participants. Then we have the constructor, everything fine here. And in the enter, we set the references to that. Now, there's one thing different, and this is the catch participants array that I created here. Now, I want to let the catcher move to the closest runner that there is. So the way I do this is at the beginning of this state, I create an array and I just use GameObject.find objects of type catch participant. So I get every catch participant in the game and save it into this array. And then it's quite easy to just determine which participant is the closest one. So I override the fixed update method. And in here, I'm also doing something rather similar to when I'm moving away. So let's just code it and talk about it then. All right, so let's talk about it. Now, this might be a little bit confusing for now. We're also not finished here quite yet. So what are we doing here? We first determine the position of the closest runner. And I don't know yet how we're going to do that. I just said there might be a method that does exactly that. Right, then we say go from our position to the position where the closest runner is and normalize this vector. So we move at the same speed every time. And then we again just say motor dot move direction equals the run direction that we've decided we want to run for. Good. So that's similar to the thing we did previously. Now we also need to determine who is the closest runner. So I'll just copy a little bit of code. I mean, it's not really the purpose of this video. So let's leave it at that. We just check the minimum distance and then iterate over this array of the catch participants. And yeah, we just save the closest participant in this variable. And then we return closest participant dot transform dot position. Okay, so let's save this now. And now we still need to do something very important. If I look into the AI controller, I can see every enemy starts in the fleeing state. So we have no transitions in there yet. Now I need to create these transitions in order to make the enemy chase. So what I need to do now is to implement these transitions. And this can be done rather easily in here. I can say check for this catch participant script. And from this catch participant script, I use the variable catch role. And this role saves if it's a catcher or if it's a runner. So I can say if the role is currently a runner, I need to switch my state. Okay, so here you can see very nicely that the role that the logic for the game has actually implemented is completely decoupled from the AI. So my AI might still run the catcher behavior even if the role is in the runner mode. So that might be nice, but it might also be a source of an error. So what I need to do is, if I am in the chasing state and the role from the logic of the catch participant changes to runner, I need to set my state to the fleeing state. So let's just say from the state machine, I'll set the current state to a new instance of the fleeing state. And I tell it to use the game object and the state machine that this state used. And I'm going to do just the same thing inside of the fleeing state. So if the fixed update is called and the role is no longer runner, but instead it is a catcher, I will set the current state to a chasing state. Right, save all of this, go back to Unity. Let's see if this works. Okay, so now back in Unity, let's hit play. And we can see we've got a couple of guys moving away from us. Now let's see, yes, they are running away just nice. Now let's catch one of those guys. And you can see he follows me around. Now he catches another guy and that follows me around. And our basic implementation is already done. So that's already our state pattern at work here. Now I also did make it a little bit more appealing by adding yet another state where they taunt the chaser by just trying to keep a certain distance from him. So now I want to show you one of the beauties of this design pattern. So instead of creating a completely new state from scratch, I will just use what we already have. And we already have a fleeing state, and I can just use all of that and inherit from it, change something a little bit up, and then we have a very similar state but slightly different without too much effort. So let's create the taunt fleeing state, which tries to maintain a distance of about 5 meters, for example. And we will just clear everything up. And instead of inheriting from the basic state, I will instead inherit from the fleeing state, which already has most of the stuff I need. Now, it still has an error. That's because I need to provide it with a constructor. So let's do this. And now let's see what we need to change up. So we're going to the fleeing state. We will need the character motor. We're going to need the catch participant, and the enter stuff can be just used from the parent class. Here in the fixed update, we will need to change that up slightly. So we will do that differently. Now I will make those two protected so I can use them in the taunt fleeing state. And yeah, we will inherit all of that, but we will override and change this fixed update completely. Now I'll just copy that stuff and go to the taunt fleeing state. And I just need to, whoopsie, override first the fixed update. And here I insert that stuff. I don't want the base stuff to be called because I want to completely change it. So I pasted that here, and we still want the fleeing direction. However, we are going to move to a different target. Let's say we create a target position. And then we want to move from the current position to the target position. And we use the normalized version of that. And the target position should be the catcher position plus the direction where we want to flee from it. So we use plus this one times how many meters we want to be away. Let's say we want to be 5 meters away from him, and that's already it. And once he gets caught, he changes back to the chasing state. Let's try if that works. That's it. And it doesn't work. Nice. Of course it doesn't work because they are at the beginning in the default fleeing state and not in the taunt fleeing state. So let's change this up. Now let's go to the enemy script or the AI script. And here we can see we start them in the fleeing state. And we don't want them to be in the fleeing state at the beginning. We want them in the taunt fleeing state. Now save and go back to Unity. And let's hit play. And as you can see, they try to maintain a distance. And as soon as I catch one, and it catches me again, this guy runs for it. So it won't keep a distance because now it's in the other state. So it really runs for it. Now, one thing we still might fix is this chittering. And there's, at least I think, something that's very funny we could do here, because right now you can see I can still catch them if they run away, if I'm smart, which I'm not. But we can make this a little bit funnier by not normalizing this. Now we have a very funny effect, because firstly, they don't chitter anymore, and also they become faster the closer I am to them. So I can never catch them unless I corner them in one of the edges. So like this, for example. But it's I think it feels very funny because they just get so fast you can never get them. And that's quite a nice experience here. So now let's corner one. And now he's the catcher, and he catches the next one immediately and tries to run for it. And now you can also see he shat his pants and runs for it and doesn't keep the distance anymore. And now everybody's in this state. Okay, so that's the exercise. I know I went a little overboard. It's a rather long video. But we also implemented some features that were not that mandatory. Okay, so that's it for the state pattern. Now, I'm not the biggest fan for creating such simple AIs as this, but next we're going to look at behavior trees, and that's what I'm a huge fan of. Now, if you're a fan of RimWorld or Oxygen Not Included, this is a very nice way of implementing AI that can do this kind of things. Behavior trees are a very nice way of implementing very complex behavior very easily, so that even a game designer without a huge coding background can adapt the AI of the game. So I'll see you in the next video.